Hello everyone, in this video, let's learn how to solve this 2025 MIT Integration B qualifying exam question. Alright, the integral of s plus square root of s over 1 plus square root of s ds. Now, observe that the top you can factor square root of s out, so it turns out to be the antiderivative of square root of s times 1 plus square root of s over 1 plus square root of s. Now this guy and this guy cancel out. So it turns out to be the antiderivative of square root of s left, right? Now you can convert the radical into the exponent. So it could be s power of 1 half ds, right? So it turns out to be s power of 1 half plus 1, it could be 3.5 over 3.5, right? Plus c. Alright, so I just flip this one. It's gonna be 2 over 3 s power of 3 half plus c. This one is the final answer. If you have another way to solve this problem, please leave a comment. The antiderivative of e to the s plus 1 over e to the s plus 1 ds. Alright, observe that you can break the top down. It turns out to be the antiderivative of e times e to the s over e to the s plus 1 ds, right? So I can bring e to the front because it's a constant, right? So I have e times the antiderivative of e to the s over e to the s plus 1 ds, right? Now, you have e to the s plus 1. What if you take derivative of this one? So I'm going to take derivative of this one to see what happens. Does that mean derivative of e to the s? It could be e to the s ds, right? Derivative of 1 is could be 0, right? So, look at the top right here. E to the s ds, right? I can replace this guy with this guy right here. Alright, so this guy turns out to be e times antiderivative of d of e to the s plus 1 over e to the s plus 1, right? Now you have the formula antiderivative of ds over s is going to be natural log of absolute value of s plus c, right? Now look at this one right here. This guy and this guy, they're both the same, so you can apply this formula. So it turns out to be e times natural log of absolute value of e to the s plus 1 plus c, right? Now, since e to the s is positive number, and if you add 1, it's always positive, right? So you can remove the absolute value side right here without changing anything. So it turns out to be e times natural log of e to the s plus 1 plus c. This one is the final answer. If you have another way to solve this problem, please leave a comment. The antiderivative of cube root of 3 sine s minus sine 3s ds. Alright, so we see that this angle right here is triple this angle. So we need to convert this one to this one by using the formula sine 3s equals 3 sine s minus 4 sine cube s. Alright, so this guy turns out to be the integral of cube root of 3 sine s minus 3 sine s plus 4 sine cube of s, right? ds. So this guy turns out to be the antiderivative of cube root of 4 sine cube s ds, right? Now I'm going to split this one into two different radicals, right? So it turns out to be cube root of 4 the antiderivative of sine s ds, right? Now the antiderivative of sine s is going to be negative cosine s, right? So it's going to be negative cube root of 4 times cosine s plus c. This one is the final answer. If you have another way to solve this problem, please leave a comment. The integral of natural log of s to the natural log of s to the s over s squared ds when s go from 1 to e to the e. Alright, recall you have log base a of b power of k. You can bring k to the front. So it turns out to be k times log base a of b, right? So k in this situation is going to be this guy right here, right? So I just write natural log of s to the natural log of s to the s. It turns out to be natural log of s to the s times natural log of s, right? So I can print this one to the front one more time. So it will be s natural log of s times natural log of s, right? So it's going to be s times natural log of s all together square, right? So this guy turns out to be the integral from 1 to e to the e. Natural log of s all together square times s over s squared ds, right? Now, this guy cancel out. So, I have the integral from 1 to e to the e. Natural log of s all together square over s ds, right? So, I can use substitution, right? So, I'm gonna let u be natural log of s. So, du equals 1 over s ds, right? And I just change the bound. When s equals 1, s equals e to the e, then you have u equals natural log of 1 equals 0, u equals natural log of e to the e. You can bring e to the front, so it's going to be e natural log of e. Natural log of e equals 1, so it's going to be e, right? So this guy becomes the integral from 0 to e u square du, right? So it turns out to be u q over 3 evaluated from 0 to e, right? So you substitute e, it's going to be e q over 3. This one is the final answer. If you have another way to solve this problem, please leave a comment. The integral from negative pi over 2 to pi over 2 of cosine of 20s times sine of 25s ds. Alright, so in order to solve this problem, look at these limits right here. Whenever you see the opposite limits, think about the even and odd function. So you have the formula, the integral from negative a to a of f of s ds equals 0 if f of s is odd, equal to 2 integral of 0 to a of f of s ds if f of s is even. Alright, so we look at this one right here, f of s right here. So we have f of s equals cosine of 20s times sine of 25s, right? Now we need to check f of negative s equals cosine of negative 20s times sine of negative 25s, right? Now cosine of s is even, right? Then cosine of negative s equals cosine of s. Sine of s is odd, right? So then sine of negative s equals negative sine of s, right? So this guy turns out to be cosine of 20s because the cosine function is even. This guy becomes negative sine of 25s, right? So I put negative sign in the front, right? Now, this guy is the same thing as negative f of s, right? So, since you have f of negative s equals negative f of s, the function f of s is odd, right? So if f of s is odd, we're gonna apply the formula right here. It's gonna be 0, right? So we say f of s right here is odd, right? So then this integral equals 0, right? If you have another way to solve this problem, please leave a comment. The integral from 0 to 2 pi of sine s, cosine s, tangent s, cotangent s, secant s, cosecant s, ds. Alright. Now we have tangent s times cotangent s equals 1, right? We have sine s times cosecant s equals 1, right? We have cosine s times secant s equals 1, right? So then this guy becomes the integral from 0 to 2 pi. This guy and this guy cancel out, right? This guy and this guy cancel out. This guy and this guy cancel out, right? So then this guy becomes 1 ds, right? So it's gonna be s evaluated from 0 to 2 pi. So it could be 2 pi, right? This one is the final answer. If you have another way to solve this problem, please leave a comment. The antiderivative of s times natural log of s times cosine s minus sin s over s times natural log of s altogether square ds. Alright, so go ahead, split this one into two fractions to see what happens. So it's going to be s times natural log of s times cosine s over s times natural log of s altogether square, right? Minus sin s over s times natural log of s altogether square, right? Now, we're going to simplify this one. S and s cancel out. Natural log s cancel out. So we have cosine s over natural log of s minus sin s over s times natural log of s times natural log of s, right? Now, we're gonna let u's equal this one. So, we have u equals sin s over natural log of s. Then we're going to take derivative both sides, right? So we have du equals. Now we're going to apply the formula, the quotient rule, u over v altogether derivative. It's going to be u prime v minus v prime u over v squared, right? So v in this situation is going to be this guy right here. And u is going to be this guy, right? So we have derivative of s could be cosine s, right? Times natural log of s minus derivative of natural log of s could be 1 over s times sin s, right? Over natural log of s altogether square, right? Now we look at the bottom right here. We need s times natural log of s times natural log of s, which means s times natural log of s altogether square. Now we already have natural log of s altogether square, right? So we need s. So we need to multiply the top and bottom by s, right? So I have s right here, s right here, multiplied by this guy, right? So I'm gonna distribute s times cosine s times natural log of s, right? minus s times this one is going to be cancel out, right? So we have sine s left, right? Over s times natural log of s altogether square ds, right? We're gonna go back to the original integral right here. So this guy right here actually du here, right? So I just replace this one with du, so it can be antiderivative of du, right? So it can be u plus c, but u equal this guy right here, right? So it's gonna be sine s over natural log of s plus c. This one is the final answer. If you have another way to solve this problem, please leave a comment. The integral from 1 to 2 of 2 to the s minus 1 plus log by 2 of 2s ds. Alright, so we're going to split this one into two integrals, right? So the first one is going to be integral from 1 to 2 of 2 raised to the s minus 1 ds, right? Plus the second one, integral from 1 to 2 log by 2 of 2s ds, right? Now I'm going to call this one I1. I call this one I2, right? Now I need to calculate I1. So recall we have the formula, the antiderivative of a raised to the s is going to be a raised to the s over natural log of a plus c, right? In this situation, it's not a to the s, it's a to the s plus something, so it's going to be like this. A to the ms plus b ds, it turns out to be a to the ms plus b over m times natural log of a, right? Don't forget to add c. Alright, so we're gonna apply this formula into this situation, right? So this guy turns out to be 2 raised to the s minus 1. M in this situation is 1, right? So this one over 1 times natural log of 2, right? Because a in this situation is 2. Evaluated from 1 to 2, right? So you have 2 power of 2 minus 1 is going to be 1 over natural log of 2 minus 1 substitute over here is going to be 0. So 2 power of 0 is going to be 1. So it's going to be 1 over natural log of 2. So you subtract this one, it's going to be 1 over natural log of 2, right? Now let's calculate the second one, I2. We have the formula log base A of B times C is going to be log base A of B plus log base A of C, right? So I'm going to split this one into two integrals, right? So integral from 1 to 2 log base 2 of 2 ds, right? Plus the integral from 1 to 2 log base 2 of s ds, right? Now this guy turns out to be 1, right? So integral from 1 to 2 of ds, right? Then it's going to be s evaluated from 1 to 2. So it could be 2 minus 1 is going to be 1, right? Now for this one right here, I need to apply the formula log base A of B equals natural log of B over natural log of A, right? So this guy turns out to be plus integral from 1 to 2 natural log of s over natural log of 2 ds, right? So I can bring natural log of 2 to the front, so it's going to be plus 1 over natural log of 2 integral from 1 to 2 natural log of s ds, right? Now I need to calculate this guy, right? So I need to use the integration by part. Now I'm gonna let u be natural log of s, then du equals 1 over s ds, right? And dv equals ds, then v equals s, right? So this guy becomes u times v, which means s times natural log of s evaluated from 1 to 2 minus v du is going to be integral from 1 to 2 v du, v right here, du right here is going to be this guy right here, right? So you multiply this one, it's going to be ds, right? So substitute 2 over here, it's going to be 2 natural log of 2, and then substitute 1 over here, natural log of 1 equals 0, right? So I don't need to worry about this guy. Minus, this guy turns out to be s evaluated from 1 to 2. Alright, so it's going to be 2 natural log of 2 minus 2 subtract 1, right? So it's going to be 2 natural log of 2 minus 1, right? Now I need to combine this guy right here, right? So I need to divide this guy by natural log of 2, right? So it could be 2 natural log of 2 divided by this one, it could be 2. And then this guy turns out to be negative 1 over natural log of 2, right? Alright, and don't forget 1 right here, right? You need to add 1. So if you add 1, it's going to be 3 minus 1 over natural log of 2. This one is the value of I2, right? Now I need to add I1. I1 equal this one, right? So if you add I1 and I2, this guy and this guy right here cancel out, right? I only have 3 left, right? So the final answer must be 3. If you have another way to solve this problem, please leave a comment. The integral from 0 to 1, s to the 2024 times 1 minus s to the 2025 altogether to the 2025 ds. Alright, so let's try use substitution. So let u be 1 minus s to the 2025, which is this guy right here, right? So du is negative 2025 s to the 2024 ds. Now we're going to change the lower limit and upper limit. So when s equals 0 and s equals 1, u becomes s equals 0, substitute over here, it's going to be 0, so 1 subtract 0 equals 1, right? So u equals 1. S equals 1, substitute over here, it's going to be 1. So 1 subtract 1 equals 0, right? So u equals 0, right? So you have this guy becomes the integral from 1 to 0. Don't forget the negative side right here because du equals this one right here. So you have s to the 2024 times ds right here equals du divided by negative 2025, right? So negative 1 over 2025 and you put du right here, right? Now 1 minus s to the 2025 equals u, right? Right here. So it could be u to the 2025, right? So if you take antiderivative of this one, it's going to be negative 1 over 2025 u to the 2026 over 2026 evaluated from 1 to 0, right? Now this guy becomes, you substitute 0 over here, it's going to be 0, right? So it could be 0 subtract negative 1, substitute over here, it's going to be 1, right? So it could be 1 over 2025 times 2026, right? Negative times negative is going to be positive. So the answer is 1 over 2025 times 20, 26. This one is the final answer. If you have another way to solve this problem, please leave a comment. Integral from 0 to 10 of s times s minus 1 half times s minus 1 ds. Alright, so this is actually a polynomial with degree 3. So you just distribute this one. Right, now let f of s equal that 1. So I distribute it. It could be s squared minus 1 half s, right? And then multiply by s minus 1. Now I'm going to distribute this one more time, right? So s squared times s could be s cubed. S squared times negative 1 is going to be negative s squared. Minus 1 half s squared, right? Plus 1 half s, right? Now I'm going to simplify. It could be s cubed minus 3½ s squared plus 1 half s, right? So I put it over here. It's going to be integral from 0 to 10 of s cubed minus 3½ s squared plus 1 half s ds, right? So it turns out to be s to the 4 over 4 minus 3 over 2 times 3 s cubed plus s squared over 2 times 2. Evaluated from 0 to 10, right? So I substitute 10 for s. It turns out to be 10 to the 4 over 4, right? Minus 3 and 3 cancel out. 10 cubed over 2 plus 10 square over 4, right? Substitute 0 over here. Every single thing equals 0, right? So it's going to be 10 to the 4. It could be 10,000. 10,000 divided by 4 is going to be 2,500, right? Minus this one is 1,000 divided by 2. It could be 500, right? And plus 100 divided by 4. It could be 25. So it's going to be 2,025. This one is the final answer. If you have another way to solve this problem, please leave a comment. The integral of the 3 over 1 root of s, the 4 over 2 root of s, the 5 over 3 root of s, the 6 over 4 root of s, etc. ds, right? So you want to convert this one to rational exponent. So it turns out to be s raised to the 1 over n1 times s raised to the 1 over n1 times n2 times s raised to the 1 over n1 times n2 times n3, right? Now, to simplify this one, does that mean you need to write s and you're gonna add all exponent up, right? Add 1 over n1, n2 plus 1 over n1, n2, n3, right? Etc. Right? So let's p equals 1 over n1 plus 1 over n1, n2 plus 1 over n1, n2, n3 plus etc. Right? So we need to calculate this one. Then we have s power p, right? Now, what is n1? n1 actually this guy right here, right? So it's going to be 1 over 3 over 1, which means 3, right? Plus 1 over n1, which means 3. Now n2, which means this guy right here, 4 over 2, right? Now 4 over 2, which means 2, plus 1 over n1, which means 3, n2, which means 2, n3, which means 5 over 3, right? So I put 5 over 3 right here. plus 1 over n1 which means 3, n2 which means 2, n3 which means 5 over 3, and n4 which means this guy, right? 6 over 4, etc. Right? Now I need to simplify this one. Right? So this guy turns out to be 1 over 3 plus 1 over 6 plus 1 over 3 and 3 cancel out, it could be 10 plus 1 over 3 and 3 cancel out, 2 and 4 cancel out, right? 5 times 6, it could be 30 divided by 2 right here, it could be 15 plus etc. The general term for this one is 1 over. Since this one is the denominator, right? So I could just call this one dk. What I need to do is to find the general terms for this one, right? So we look at this one, we see the rule. This is the first term. This is the second term. This is the third term. And this is fourth term, right? Now we need to find the relationship between this number right here and the number of terms right here, right? So we see that 3, which means 1 plus 1 times 1 plus 2 divided by 2. Now 6, which means the second term right here, 2 plus 1 times 2 plus 2 divided by 2. Now 10, which means the third term right here, it's going to be 3 plus 1 times 3 plus 2 divided by 2. Now 15 right here related to 4, right? So it can be 15 equals 4 plus 1 times 4 plus 2 divided by 2. So dk right here, which means kth term, right? So this is going to be dk equals k plus 1 times k plus 2 divided by 2, right? Now 1 over dk, which means 2 over k plus 1 times k plus 2, right? Now I need to find the sum of this series with the general terms right here when k goes from 1 to infinity, right? Now s to the p becomes s to the sum of 2 over k plus 1 times k plus 2 when k goes from 1 to infinity, right? Now I need to calculate this guy, right? So I put this guy on the side, it could be, I can bring 2 to the front, it could be the sum when k goes from 1 to infinity of 2 times 1 over k plus 1 times k plus 2. This guy actually the telescoping series, right? So you can use partial fraction decomposition to decompose this one. So this guy turns out to be the sum when k goes from 1 to infinity of 2 times 1 over k plus 1 minus 1 over k plus 2, right? So it's gonna be 2 times. Now k equals 1, substitute 1 for k, right? So we have the first one is gonna be 1 over 2 minus 1 over 3 plus, if k equals 2, you have 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5, right? Plus etc. Subtract subtract 1 over n plus 1 plus 1 over n plus 1 subtract 1 over n plus 2. Right, this one is the last term, right? So we see that this guy cancel out. This guy cancel out. This guy cancel out. This guy cancel out, right? So you only have 2 times 1 over 2 minus 1 over n plus 2, right? Now, for this one right here, I can write limit of this one when n approaches infinity, right? This guy right here. So when n approaches infinity, this guy approaches 0, right? So you only have 2 times 1/2 left, right? So it could be 1, right? So then we go back over here. It's gonna be s power of 1. It's gonna be s, right? So finally, this guy becomes the integral of s ds, right? So it could be s squared over 2 plus c. This one is the final answer. If you have another way to solve this problem, please leave a comment. The integral of e to the 2s times s squared plus s divided by s times e to the s altogether raised to the 4 plus 1 ds. Alright, so let's try substitution. Let u be s e to the s. Then you have du equals, we're going to use the product rule. U times v altogether derivative is going to be u prime v plus v prime u, right? So it's going to be e to the s plus s times e to the s, right? Now we're going to factor e to the s out, so it's going to be e to the s times s plus 1 ds. Alright, let's call this one I. So I becomes the antiderivative of, now e to the 2s, I'm going to rewrite this one as e to the s times e to the s. Now s squared plus s, I'm going to factor s out, so I'm going to put s over here, right? Then I have s plus 1 right here, right? Over s times e to the s all together raised to the 4 plus 1 ds, right? Now, observe that this one actually u, right? This guy right here actually du, right? This one is u, right? So I becomes antiderivative of u du over u to the 4 plus 1. Now let's try substitution one more time. So I'm gonna let v be u squared. Then dv equals 2u du, right? So then dv divided by 2 equals u du, right? Now I'm going to substitute back over here, so I becomes the antiderivative of dv over 2 times v squared plus 1, right? Now I bring 2 to the front, so it's going to be 1/2 here, right? Now you have the formula antiderivative of ds over s squared plus 1. It's going to be tangent inverse of s plus c, right? So this guy becomes 1/2 tangent inverse of v plus c, right? Now, since v equals u squared, right? So I'm going to have 1/2 tangent inverse of u squared plus c. But u equals this guy, right? So it's going to be 1/2 tangent inverse of s e to the s all together square plus c. This one is the final answer. If you have another way to solve this problem, please leave a comment. The antiderivative of secant to the 4 of s minus tangent to the 4 of s ds. Alright, so we're gonna apply the formula a square minus b square equals a minus b times a plus b, right? This is a difference of 2 square formula, right? So secant to the 4, it turns out to be secant square of s all together square minus tangent square of s all together square ds, right? So I'm going to apply this formula. It's going to be antiderivative of secant square of s minus tangent square of s times secant square of s plus tangent square of s ds, right? Now I have the formula tangent square of s plus 1 equals secant square of s. Alright, this guy is the trig identity. Now, if you want to learn how to memorize the trig identities, please check out the video in the description below. Alright, so from here, I just subtract tangent square of s both sides. So it's going to be 1 equals secant square of s minus tangent square of s, right? So this guy right here becomes 1, right? So I only have the integral of secant square of s plus tangent square of s ds, right? Now, same formula right here, I can solve for tangent square of s. It's going to be secant square of s minus 1, right? So, this guy turns out to be 2 secant square of s minus 1 ds, right? Now you know that antiderivative of secant square of s equals tangent s, right? So I'm going to split this one into 2 integrals. The first one is going to be 2 secant square of s ds minus antiderivative of ds, right? So this guy turns out to be 2 tangent s minus s and plus c, right? This one is the final answer. If you have another way to solve this problem, please leave a comment. The integral from 0 to 1 of square root of s times 1 minus s ds. Alright, so I'm going to put this one on the side, s times 1 minus s. Right, now I'm going to distribute this one. It turns out to be s minus s squared, right? So I can factor negative side out. So it turns out to be negative of s squared minus s. Now I'm going to make this one as a complete square by adding and subtracting 1/4, right? So it turns out to be negative of s squared minus s plus 1 over 4 minus 1 over 4, right? Now the first 3 terms right here becomes a complete square, so it turns out to be negative of s minus 1/2 all together square. Now I'm going to distribute negative 1 over here. So it turns out to be plus 1 over 4. This guy is the same thing as 1 over 4 minus s minus 1/2 all together square, right? Now I'm going to bring this guy back to the original integral. So it turns out to be the integral from 0 to 1 square root of 1 over 4 minus of s minus 1/2 all together square ds, right? Now if you have the antiderivative of a squared minus u squared du, then you're going to use trig substitution, which means you're going to let u equals a sine theta, right? So I'm going to apply this method into this integral right here. In this situation, u, which means s minus 1/2, right? A, which means 1/2, right? So I'm going to let s minus 1/2 equals 1/2 sine theta, right? Then ds equals 1/2 cosine theta, right? Now I need to change the upper limit and lower limit, right? Now s equals 0. Substitute 0 for s into this equation. So you have negative 1/2 equals 1/2 sine theta, right? Now divide both sides by 1/2, so sine theta equals negative 1, right? Then theta equals negative pi over 2, right? Now when s equals 1, then you substitute 1 for s into this one, so it turns out to be 1/2 equals 1/2 sine theta, right? It's the same thing as sine theta equals 1, right? Or theta equals pi over 2, right? This integral becomes the integral from negative pi over 2 to pi over 2 square root of 1 over 4 minus 1 over 2 sine theta all together square. Now ds becomes this guy right here, right? So it could be 1/2 cosine theta d theta. I forgot d theta here. 1/2 square is going to be 1/4, right? So I put this one as 1/4 and this one square, right? So I remove square root right here. Now I factor 1/4 out, and then I'm going to print it outside the square root. It turns out to be 1/2, right? 1/2 right here and 1/2 right here becomes 1/4, right? So I put 1/4 in the front. The integral from negative pi over 2 to pi over 2 square root of 1 minus sine square theta, right? Times cosine theta d theta, right? Now this guy is the same thing as 1 over 4, the integral from negative pi over 2 to pi over 2. 1 minus sine square theta equals cosine square theta, right? Now I need to print this one outside the square root, so it turns out to be absolute value of cosine theta times cosine theta d theta. Now on the unit circle, the x-axis represents the cosine function, right? The y-axis represents the sine function, right? Now, look at the interval from negative pi over 2 to pi over 2, which means it's going to be from here to here, right? Which is the first quadrant and the fourth quadrant. Right, within this quadrant, cosine is positive, right? It's going to be right here, right? So then, when I remove the absolute value sine right here, I don't need to change the sign of cosine theta, right? So this guy becomes 1 over 4, the integral from negative pi over 2 to pi over 2 cosine square theta d theta, right? Now we have the formula cosine square theta is going to be 1 plus cosine 2 theta over 2, right? So this guy becomes the integral form negative pi over 2 to pi over 2. Now, you have 1/2 right here. I bring it to the front. It's going to be 1 over 8, right? And I have 1 plus cosine 2 theta d theta, right? So this guy becomes 1 over 8. Now, antiderivative of 1, which means theta, right? So I have theta right here. And antiderivative of cosine 2 theta is going to be plus 1/2 sine 2 theta. Evaluated from negative pi over 2 to pi over 2. Right? Recall sine of as plus b ds. When you take antiderivative of this one, it's going to be negative 1 over a cosine of as plus b plus c, right? If you have antiderivative of cosine of as plus b ds, right? It turns out to be 1 over a sine of as plus b plus c. So keep that in mind. Alright, so I substitute pi over 2 for theta into this expression. So it's going to be 1 over 8 times pi over 2 plus 1/2 sine of 2 times pi over 2, which means sine pi, right? And then I subtract this guy. It's going to be subtract negative pi over 2. Substitute over here. It's going to be negative pi over 2. And then when I subtract this one, it turns out to be plus pi over 2, right? Now, negative pi over 2. Substitute over here. You have negative 1/2 sine of negative pi, right? Pi over 2 plus pi over 2 is going to be pi, right? So I have 1 over 8 times pi, right? Now, sine pi equals 0, right? This guy is 0. Now, sine of negative pi is going to be negative sine of pi, right? And it's still 0, right? So, the final answer must be pi over 8. If you have another way to solve this problem, please leave a comment. The integral of sine 4s cosine s over cosine 2s sin s ds. Alright, recall we have the formula sine 2s equals 2 sine s cosine s. This one is the double angle formula. Alright, now observe that this angle right here always double this one and this one, right? So if you have sine 4s right here, this guy must be 2s. This guy must be 2s, right? So I'm gonna print this one over here. So it turns out to be the antiderivative of 2 sine 2s cosine 2s times cosine s over cosine 2s times sine s ds, right? Now this guy cancel out, right? Now sine 2s right here, I can apply this formula one more time. So it's gonna be the antiderivative of 2 times 2 sine s cosine s, right? Times cosine s over sine s ds, right? Now this guy and this guy cancel out, right? So you have the antiderivative of 4. I'm gonna put in the front, right? Because 2 times 2 cosine times cosine could be cosine square of s ds, right? Now cosine square of s equals 1 plus cosine 2s over 2, right? So then I bring it over here. It turns out to be the antiderivative of 1 plus cosine 2s over 2. I put 4 outside, right? ds. Now 4 and 2 right here cancel out, right? So I have 2 left, right? So it could be 2 times antiderivative of 1 plus cosine 2s all together ds, right? Now it's gonna be 2 times antiderivative of 1 is gonna be s. This guy is gonna be plus 1 half sine 2s plus c, right? Now I'm gonna distribute 2, so it can be 2s plus sine 2s plus c. This one is the final answer. If you have another way to solve this problem, please leave a comment. The integral of sine s times hyperbolis sine s ds. Alright, so we're going to use integration by part. So we're going to let u be sine s. Then we have du equals cosine s ds, right? Now dv equals hyperbolis sine s ds. Then v equals hyperbolis cosine s. Alright, now you have the formula antiderivative of u dv equals u times v minus antiderivative of v du. Now I'm going to let this one be I. So I becomes u times v, u equals this guy, v equals this guy, right? So we have sine s times hyperbolic cosine of s, right? Minus antiderivative of v du, right? V equals this guy right here. So it can be hyperbolic of cosine s times du is going to be right here. Cosine s ds, right? Now we're going to use integration by part one more times for this guy right here. So I'm going to let u be cosine s, then du equals negative sine s ds, right? dv equals hyperbolic cosine of s ds. Then v equals hyperbolic sine s, right? Now I'm going to apply this formula one more time for this guy only, right? So it turns out to be u times v, u equals this guy, v equals this guy, so it can be cosine s times hyperbolic sine s minus antiderivative of v du, v equals this guy, so hyperbolic of sine s du is going to be this one times negative sine s ds, right? Now I becomes sine s times hyperbolic cosine of s minus, now this subtraction sign right here is the sine of this guy right here, right? So it's going to be cosine of s times hyperbolic sine of s. Negative side right here and negative side right here becomes positive. So then I distribute this one, it's going to be negative, right? Now this guy right here, actually the initial one right here is I, right? So I have minus I, right? Now I'm going to add I both sides. So it could be 2I equals sine s hyperbolic cosine s minus cosine s hyperbolic sine s, right? Now I'm going to divide both sides by 2. So this guy turns out to be 1/2 of this guy right here plus c. This one is the final answer. If you have another way to solve this problem, please leave a comment. The integral from 0 to pi over 3 of sine s cosine of pi over 3 minus s ds. Now we need to apply the product to some trigonometric identity to expand this one. So we have sine a cosine b equals 1/2 sine of A plus B plus sine of A minus B, right? In this situation, A is S, right? B is pi over 3 minus S, right? So this guy turns out to be the integral from 0 to pi over 3. 1/2 I'm going to put in the front, right? It's going to be sine of A plus B, which means S plus this guy, it turns out to be pi over 3, right? Plus sine of A minus B. So this guy subtract this guy, it's going to be 2S subtract pi over 3, right? ds. Now we're going to split this guy into two integrals, right? The first integral is going to be this guy right here. I call this I1. The second integral is going to be this one. I call this I2, right? Now I need to calculate I1 first. So I1 equals the integral from 0 to pi over 3 sine of pi over 3 ds, right? Sine pi over 3 equals root 3 over 2, right? So this guy turns out to be the integral from 0 to pi over 3 of root 3 over 2 ds, and it's going to be root 3 over 2 as evaluated from 0 to pi over 3, right? So it's going to be pi root 3 over 6. Now go ahead, calculate I2. I2 equals the integral from 0 to pi over 3 of sine of 2s minus pi over 3 ds, right? Now we're going to use substitution. So let's use equals 2s minus pi over 3, right? Then du equals 2 ds, or ds equals du divided by 2, right? Now we need to change the lower bound and upper bound, right? So the lower bound s equals 0, upper bound s equals pi over 3, right? Then u becomes negative pi over 3, and u becomes pi over 3, right? So I2 becomes the integral from negative pi over 3 to pi over 3 sine of u times du, and then don't forget to divide by 2, so it could be 1/2 right here. Alright, now whenever you see the opposite lower limit and upper limit, think about the symmetry, right? We have the formula, the antiderivative of negative a of f of s ds equals 0 if f of s is the odd function, right? We know that sine function is odd, so this one equals 0, right? By the way, we have f of s is even, then the integral from negative a to a of f of s ds equals 2 integral from 0 to a f of s ds. So keep that in mind. Because I2 equals 0, we only have I1 left, right? Now I1 is this guy, and don't forget 1/2 right here. Alright, so finally I equals 1/2 times pi root 3 over 6 plus 0, right? So it's going to be pi root 3 over 12. This one is the final answer. If you have another way to solve this problem, please leave a comment. The antiderivative of cosine s plus cosine s plus 2 pi over 3 plus cosine s minus 2 pi over 3 altogether square ds. Alright, this antiderivative looks complex, but it's very simple. Alright, so we need to simplify this guy and this guy first by using the formula cosine of A plus cosine of B equals 2 cosine of A plus B divided by 2 cosine of A minus B divided by 2. Right? In this situation, A equals this one and B equals this one, right? So I put this guy on the side first, right? So it turns out to be 2 cosine of A plus B. This guy plus this guy equals be 2s divided by 2, right? Cosine of A minus B. So this guy subtract this guy is going to be 4 pi over 3 divided by 2. Now we need to simplify this guy. It turns out to be 2 cosine of s times cosine of 2 pi over 3, right? Now cosine of 2 pi over 3 is going to be negative 1/2, right? So it's going to be 2 times cosine of s times negative 1/2, right? So it turns out to be negative cosine of s, right? Now I call this one I. So I becomes the antiderivative of cosine of s. I just rewrite this one, right? This guy right here is this guy, right? So minus cosine of s ds, right? So it turns out to be the antiderivative of 0 ds, right? So it's going to be c, where c is a constant. This one is the final answer. If you have another way to solve this problem, please leave a comment. So first, we need to simplify the one inside parentheses first, right? Now observe that if k equals 1, what should we have? We have negative s squared, right? K equals 2, it's going to be s to the 4. K equals 3, it's going to be negative s power of 6. K equals 4, it's going to be plus s to the 8 minus etc. plus etc. Right? So observe that this one is the first term. I call this A1, right? Now, in order to get s power 4 from this one, does that mean I'm going to multiply by negative s squared, right? Every single time you're going to multiply by negative s squared to get the next term, right? So, this guy right here is called common ratio, right? And this guy actually infinite geometric series, right? So we have the formula A plus A times R plus A times R squared plus A times R cubed plus etc. is a geometric series where the first term is A and the common ratio is R. If absolute value of R less than 1, then we have the sum is going to be equals A over 1 minus R, right? Now, we need to calculate the sum of this one, right? So we know that the common ratio is negative s squared. Now we look at the lower limit and upper limit right here, 0 to 1, right? Now we're going to take absolute value of R. So absolute value of R equals absolute value of negative s squared, right? So it turns out to be s squared, right? Now, we know that s is between 0 and 1. Within this interval, you know that s squared always less than s, right? So from these two guys right here, you can say that absolute value of R equals absolute value of s squared equals s squared less than 1, right? So we can apply this formula right here. So the sum is going to be the first term. The first term is this one, negative s squared over 1 minus common ratio. Common ratio equal this one right here. So it turns out to be plus s squared, right? So this integral becomes the integral from 0 to 1 of negative s squared over 1 plus s squared ds, right? Now I can add 1 and subtract 1, so I have negative 1 and plus 1 right here. So this guy turns out to be two integrals, right? The first integral is going to be integral from 0 to 1. Now I'm going to group this guy and this guy. So I separate this one into two integrals. The first one turns out to be negative of 1 plus s squared over 1 plus s squared, right? ds. The second one is going to be integral from 0 to 1 of 1 over 1 plus s squared ds, right? Now I need to calculate this one. So this guy turns out to be the integral from 0 to 1 of negative 1 ds, right? Plus the second integral is going to be 0 to 1, 1 over 1 plus s squared ds, right? Now the first one turns out to be negative s evaluated from 0 to 1. The second one turns out to be inverse tangent of s evaluated from 0 to 1, right? So this guy turns out to be negative 1 plus this guy, substitute 1 over here, inverse tangent of 1. Now inverse tangent of 0 is going to be 0, right? So this guy turns out to be negative 1 plus pi over 4, or pi over 4 minus 1. This one is the final answer. If you have another way to solve this problem, please leave a comment. Alright, so basically on the top I just rewrite e to the s and I need to subtract 1. So that is going to be the same thing as the denominator, right? So I just subtract 1, I need to add 1, right? Then I'm going to add 1 right here, which means this guy right here, right? Over e to the s minus 1 ds, right? Now this guy and this guy right here, I combine this guy, it's going to be 2, right? Plus 2. Now I'm going to separate this fraction by taking this one divided by this guy, right? So it's going to be the integral of 1 ds, right? Plus the integral of 2 over e to the s minus 1 ds, right? Now the first one very simple, right? I need to calculate the second one. So I call this is I. So I have I equals 2 over e to the s minus 1 ds, the integral. Now in order to calculate this one, multiply the top and bottom by e to the negative s. So I have e to the negative s. This one e to the negative s, right? So this guy turns out to be the integral of 2 e to the negative s over 1 minus e to the negative s ds, right? Now side note, observe that, look at the bottom right here. If I take the derivative of the bottom 1 minus e to the negative s, does that mean I have e to the negative s ds, right? So basically I just replace this guy right here with this guy right here, right? So I have I equals, I can bring 2 to the front, the integral of d of 1 minus e to the negative s over 1 minus e to the negative s, right? Now I know that the integral of ds over s It's going to be natural log of absolute value of s plus c, right? So this guy becomes 2 times natural log of absolute value of 1 minus e to the negative s plus c, right? So the final answer is this guy at I, right? But I equal this, right? So I have the integral of e to the s plus 1 over e to the s minus 1 ds. It's going to be s plus 2 natural log of absolute value of 1 minus e to the negative s plus c, right? And this one is the final answer. If you have another way to solve this problem, please leave a comment and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.